Hey guys, today we're going to begin the rational function. Okay, so yesterday what happened is you guys went over something called variation. You learned about direct and indirect, or it's also called inverse, alright? Variation. Okay, the rational function is basically just something that we take inverse or indirect variation and we expound on it completely, okay? So you'll remember that indirect or inverse variation, same thing, looks something like this. Y equaled k over x, right? Well, where was x? It was in the denominator. This is the parent function for the rational function. Remember, a parent function means there's been no changes done to it. Y equals 1 over x. Okay? So you see the similarity? See the similarity we got going on? Okay? In indirect variation, there's something called a constant of variation. Rational functions, we don't have a constant variation. All right? What we have is we just have inputs. That's your x. And you chug away, and then you have an output. That's your y. Okay? So what we're going to start talking about now is called the rational function. Another name you sometimes hear is not the rational function, but sometimes you hear something called the reciprocal. Okay? Reciprocal function. All right? Now, we're going to have one focus today. We want to be able to graph a very simple rational function by the end of today. All right? So let's look at, first off, what does 1 over x look like? Okay, well let me show you guys what it looks like. First I'll draw it by hand, and then I'm going to show you it on a graph that looks a little bit cleaner than what I can do. Okay, so you draw yourself your x, y. Okay, now it's important to realize, where do we get graphs? We get graphs from tables, right? So x, y. So -2, -1, 0, 1, 2. These are the 5 values I want to use to graph. Alright, now let's think about what is the function I'm graphing here. Y equals 1 over x. Okay, so if you plug in a -½ you get 1 over -2. That's just -1 over 2. Alright, you plug in a -1, you get 1 over -1. That's just, -1. You plug in a 0. Ooh, I don't know what that happened. You plug in a 0. Can you do 1 over 0? Is 1 over 0 possible? Can you divide 1 over 0? Is that a thing? No, it's not. That's not possible. So I'm going to go ahead and say that we say error here, and I'll talk to you about why we have that error. Okay, I'll tell you what that error looks like on the graph. Alright, now you plug in a 1. 1 over 1 is 1. And now you plug in a 2. 1 over 2 is 1 over 2. Okay, so let's talk about something real fast. This 0 we got right here. Are you ever going to be able to divide by 0? In other words, is there ever going to be a situation where you could have 1 over 0? No. So some of you might be tempted to say, okay, so you just simply can never plot this. Well, that's not entirely true, is it? Even though that this is an x value 0, you can't ever plot that, but that's not the only thing you can't plot. You also can't plot this, or this, or this, or this. Why can't I plot any of these? In other words, why will these never appear for 1 over x? Because I can't divide by 0. And all along this line, x is 0. And so if I tried to plot, let's say this point right here, alright, I'm sorry, that's not where x is 0. I'm dumb. That is going to be an asymptote, and we're going to talk about it in a second, but that's the horizontal asymptote, not what I'm trying to get right now. I'm sorry, it's all up and down here. This is where x is 0. X is 0 all up and down this line, right? So because of that, since x is 0 all up and down this line, this means I have a vertical asymptote right here because I cannot divide by 0. Since I cannot divide by 0, everywhere x is 0, I can't include in my graph. So what we do is we call that a vertical asymptote. Okay? So it's a line that I can never touch. We've talked about it earlier on in the year for log graphs and exponential graphs. Okay? Now, a second ago, I was plotting all along this line right here. Okay. The reason I was doing that is because what is this line? This is the line y equals 0, right? Well, let's think about that for a second. Is there ever a way that you're going to get y equals 0 right here? Well, let's see. 0 is equal to 1 over x. Okay, let's think about this. What number divided by 1 divided by it would give me 0? That's right, there is a number. There's no way to divide by a number to get 0. It's not possible. You cannot divide by a number and get 0. So in other words, I'll never get an output of 0. It's not possible. There's no input that will give me an output of 0. So therefore, I also have what's called a horizontal asymptote of y equals 0. Okay, so a key takeaway here is that rational functions have two asymptotes. They have a vertical asymptote, which I say VA, and they have a horizontal asymptote, which I say HA. The vertical asymptote is assumed to always be at x equals 0 unless I shift my graph up or down. We're going to talk about that in a second. All right, and then I have a horizontal asymptote, which is assumed to be the line y equals 0 unless I shift my graph up or down. Sorry, vertical would be shifting left or right. We'll change it, not up or down. It's already infinitely long up or down. Okay, so remember, rational functions have two asymptotes. All right, that's important. Now, let's plot some of these points. -2, -1/2. So -2, if I say that's -1, that'd be something like right there. -1, -1, so that'd be something like right there. And then if I was to include more, it's going to look like this. Because you should know that I get closer and closer to asymptotes without ever touching them. And then 1, 1, so 1, 1, 2, 1/2, so that'd be something like right here. It's going to do the same thing. So what actually the rational function looks like is something like this. Okay? It gets infinitely closer as we get close to our asymptotes, and it follows them. It just kind of follows our asymptotes around. So this is what the rational function looks like. This is what y equals 1 over x looks like. It has a domain of -infinity to 0, and then we union it, that's a u, we union it from 0 to infinity. Now, why do we do that? Because do I get to include an x value of 0? No, remember we have an asymptote there. So I never get to include it. So that's why I say it goes from -infinity, so that's this arrow. It's coming from -infinity all the way to an x value of 0. It skips over that x value and picks up on the other side and continues on forever to the right. So that's why we say 0 to infinity. The range is, oh, and let me show you another way you could write that. Since there's only one x value I cannot include, your domain, you could also just write x cannot equal 0. Okay? Now your range is the exact same thing, but for a different reason. It's -infinity to 0, union, so we draw a u, with 0 to infinity, and then we also say that y cannot equal 0. Either one of these ways is writing it is fine. One's just interval, one's inequality. Now why do I get to say it? Because I have a horizontal asymptote. That's why y can't be 0. Alright, and that's pretty much all there is to graphing this guy. Alright? So rather than making it this hard every time, really what you really just want to remember is this information. Okay? If you can remember this information, then you just need to change it based on the transformations of the graph. Let's look at a problem. Okay? Let's say I give you the function f of x is equal to negative, we'll talk about what that does, 1 over x plus 1 plus 1. Okay, so first, let's talk about a couple things. What does this negative sign do to the graph overall? That's right, it makes it reflect. It reflects the x-axis. Reflects across the x-axis. I'm just going to write reflects, but you should know it reflects across the x-axis. What does this plus 1 do? Well, it's down there with the x, and it's plus, so that means left 1. So it means left 1. Okay, and then what does this plus 1 do? Well, it's outside the function, so that means up 1. Okay, so then let's review some things. We had a vertical asymptote and a horizontal asymptote. Now remember, the vertical asymptote was at x equals 0. That's where the vertical asymptote was. It was at x equals 0. And remember, the vertical asymptote is an infinitely long up and down line, straight up and down. Well, do any of these transformations affect going straight up and down? Well, let's talk about it. Reflecting. No, if you reflect a straight up and down line, it's just going to reflect over itself. It's just going to look the same. But what about left 1? Can you move a straight up and down line left 1? Yes, you can. So instead of being at x equals 0, it's now at x equals -1. Very good. All right. Up 1. Is moving up 1 going to affect a straight up and down line? No, it's already straight up and down. It's not going to go more up if it's already infinitely up and down. All right, what about a horizontal asymptote? Well, that was originally at y equals 0. All right. But since I'm moving, now remember, horizontal is infinitely long left to right. Is moving to the left one going to affect an infinitely long left to right line? No. What about reflecting? No, it's just going to reflect on top of itself. But what about up one? Can you move an infinitely long left to right line up one? Yes, you can. So instead of now being at y equals 0, it's at y equals 1. Great. Now with that information, you actually don't need to do a whole lot else. First thing, graph your vertical and horizontal asymptotes. So I have a horizontal asymptote at y equals 1. Okay. Then I have a vertical asymptote at x equals negative 1. Sorry, mine looks so bad. Okay. Boom, boom. Now, where were the curves in 1 over x? Top right, bottom left. But I'm reflecting, so instead of being here and here, the curves are now going to just simply be here and here. Alright? So the last thing I just want you to simply do is tell me the domain and range. Well, the domain was negative infinity 0, 0 to infinity on the parent function. But remember, that's because I had a vertical asymptote at x equals 0. This time I have a vertical asymptote at x equals negative 1. So the domain is negative infinity to negative 1, unioned with negative 1 to infinity. Or you could just say x cannot equal negative 1. What is the range going to be? I'm going to write it over here because I'm running out of space. What is the range going to be? Well, it's just going to be from negative infinity to your horizontal asymptote, which is at y equals 1, then from 1 to positive infinity. So we could just write negative infinity to 1 unioned, that's a u, not a v, with 1 to infinity. Or we could just written y cannot equal 1. Alright? Alright guys, so finish up those problems. Let me know what questions you have. Sorry I had to miss 2 days in a row for you. Okay? Have a great day.